Let's quickly, in this lecture, install NPM. And what we need to do to install NPM? Well, install Node.js, because NPM comes as a standard with the Node.js installation. Well, all you need to do is to go to the official website of Node.js, nodejs.org. Then on the first page, you will see a button for installing the latest recommended version. This is the one for me currently. Maybe by the time you're watching this, another version will be released. You can download the installer and execute it. That's it. And since we are talking about installing things, another tool that helps us a lot to develop Node and NPM projects, it's Visual Studio Code. I will use it inside this course. If you like another tools, you can use them. VS Code is great, and it also comes with a embedded terminal. If you want to use another tool, no problem, just make sure that you have a terminal, a decent one, installed. Well, how can you know that you have installed NPM or Node? Well, go to a terminal and search for or type the command npm -version. I currently have the version 9.3.1. Maybe you have installed Node a long time ago and you are seeing here a smaller version. Make sure you are using the latest version. How can you install the latest version of NPM, or how can you update it? Very easy. I will show you the command right now. This is the one, npm -g npm at latest. Well, we will talk in detail in this course about each and one of all these command and all these flags right here. This is the way you can update your NPM installation. You can call this command and make sure you have the latest one. In this lecture, we will create our first NPM project and install our first NPM package. Let's get started. I will create a new folder on my computer. I will call it npm-practice. This is the way you can give names to your NPM projects. It is the recommended way. Let's create this folder and run VS Code inside this folder. And I have opened VS Code because I will use its terminal, because we will make commands from its terminal and we will see changes in the file structure of the project. Our first command that we will talk about in this lecture is npm init, which will make an NPM project from this folder. Currently, what it will create a package JSON file. So I will call npm init. And this is a command line application which will tell us some default options. I will just press enter. I want to select the package name, it's okay. Version, it's okay. I will just press enter because no matter what, we will be able to edit this later in the time whenever we like. So a package log.json will make from this folder a Node project or a Node package. A more direct way to create a package JSON file is with npm init and pass the flag -y. This will directly call the default options and generate a package.json file. And as you can see, this initial package.json file contains some basic information of our project, but this file will grow over time. But this is the main point you will open when you will explore or create a Node project. This will contain all the information, or the most important information about your project. Let's now install a package. I will first install a package with no dependencies. And if I want to know more information about the package before installing it, I can call the command npm view, and then I will pass the name of the package. I want to know more about the package uuid, which is a package which generates random strings, a simple functionality package. And if I call this command, I will get some basic information about this package. As you can see, what I care about the most about it is that it has no dependencies. This means that when I will install this package, I will only install it, not other dependencies. I can get some other informations about this package, like its version, but one better place to search for information about NPM packages, it's the npmjs.com website, the official website of NPM, and here I can search for packages and see more information about them. I will also search for this package name right here. This is the one. And what you can see here is that it has 0 dependencies, but here I can see that it has a lot of other packages that depend on this package. This is a popular package. And also you can see that it is pretty. In this lecture, we will start to talk about the NPM scripts section. So besides handling different packages, NPM also greatly assists us at running different functionalities from our project. And as you can see in the package.json file we created in the last lecture, we have a scripts entry. Currently it has only this test entry, which tells us that no test is implemented. Let's create another entry right here, and if you're using VS Code and I'm adding a new entry in this JSON file, if I press Ctrl space, you'll see all the options that we have here that we can add. These are predetermined or default NPM scripts. They sometimes do exactly what they say, like pre-install, like post-install. But what we care about, and the most popular ones, are start and stop. Let's implement this start section, and for starting, let's just create a simple file. So I will say here node index.js, and I will save this. And let's create this file, index.js, and here just print something, hello from node, exclamation mark, very important. All right, now we have this JavaScript file inside our project. One way we can execute it is directly with Node. So here I can say node index.js if I'm in with the terminal inside this folder, and it will execute it directly. But we can also execute this file, this starting point of our project, using an npm script like the npm start. And if I configured this script like this, I can just call npm start. And again, it will execute this file. These are predetermined scripts, this test, this start, and all these predetermined scripts like here. But I can have any entry right here. I can just say a entry like hello, for example. And again, here I can say node index.js. And there's one key difference right here if I want to execute this script. I can just say here npm hello. I can do this. In order to run this script, which is not predetermined by Node, I can just call npm run hello. I had a typo. Let's try again. npm run hello. And again, it executes this file. Nothing too complicated until now. One important point I want to make is the way we can execute different scripts with Node. For example, pay attention at this generated test script. What it does, it prints something to the console, but it also does something else. It says and exit1. This means that inside our npm scripts, we can pass different executions or different points that we want to do. For example, in our start script, I can just say here, let me copy this because I'm so lazy. I can just say here, starting script, and then execute this script. And if I will say npm start, we will see first our print and then our script executing. Of course, that we can execute multiple scripts. For example, I can just say here nodeindex.js and nodeindex.js. It's exactly the same thing. And it will execute it twice, but it will execute it one after another. There are ways we can make this concurrent using a different NPM package. So we reached the end of the lecture. We saw how we can use NPM scripts. Of course, this was a very brief introduction. In the advanced section of the course, we will talk more about the NPM scripts. For the moment, you saw that we can just configure them, execute them, and we saw that there are two types of scripts. There are predetermined scripts, which we can just execute with npm start or npm test. And if we have custom scripts, we can execute them with npm run and our script. The time has come for us to use the packages that we just installed. So there are two main ways in which you can reuse or reference code in Node.js. One is the CommonJS way, and the other is the ECMAScript modules way. The default way is by using CommonJS, and that means using the require function. So if I want to use something from the UUID package that we installed previous in the course, I can just say const UUID, and I can use the require function, and here I can pass this UUID. Now I have a reference to this package and I can use its contents. So here I can just say, here is a random string, and I can pass UUID and call the v4. This is the most common way. I can use this, and let's see if this works. Let's properly format our scripts. I can just say npm start right here, make it clean, save everything and call npm start. And now I'm using the package I have imported with this constant, with the require method. Also, there's a way I can just import the v4 function. I'm not importing right here the whole package, using the JavaScript destructuring syntax. And here I can just import v4. And this way I can just import v4 from UUID, and the output will be the same. Alright, but this was the initial or the old way in which we reference things around in Node.js. The more popular way is by using ECMAScript modules or by using the import-export syntax. I prefer it because it is a little more easier to read. Even VS Code prompts us to use this approach. It tells us that file is a CommonJS module. It may be converted to my ECMAScript module. If I press quick fix and I will convert it to ECMAScript module, I will use this more modern syntax, import, and what I need from the package I want. Save everything, and let's see if this approach is working. I tell you from the start it won't. If now I can call npm start, it will tell us a very common error that you will encounter while working with Node.js. It tells us cannot use import statement outside a module. Because even if we don't have any syntax error, npm expects the require syntax. To use this modern syntax inside Node, we need to tell it to expect it. And the way we can do this is by calling in the package.json by adding the type option. By default, it is CommonJS, so it expects this CommonJS with require syntax. But if I make it a module, save this, and try again, everything works as it should. There is one disadvantage while working with this approach by using modules. The disadvantage is that not all Node packages are updated with this modern syntax, but most of them should be updated and be able to be used with this modern syntax. If a package is not updated, you should not use it anyway. And as a final note, if we are talking about reusing packages, there's one more way in which we can execute functions from this UUID module. If you remember, it registered itself in the bin folders in Node modules, and even its documentation tells us this. When I import a package, I sometimes like to just read its documentation right here from the Node modules. In VS Code, I just can select its README file and open its preview. And here it tells us, lower down the road, that it can be used in the command line. And this can be seen directly because it registered itself in the bin folder. So if I go to the package.json entry, and I can add another entry right here, I can call it directly UUID, and right here I can just say UUID. I can just execute it. So here I can say npm run UUID, and again it generates a random string. How is this possible? This is a popular interview question. What happens when I call npm run? As you can see, we have registered this command inside the scripts entry. Well, if we register this inside the scripts entry, npm what will do? It will go and search in the bin folder. In the bin folder, it finds a file for this command. And as you can see, VS Code tells us that this is a symbolic link. If I open this, it will just reference this UUID bin file. This one right here, and this will execute this library. So this is very simple. We register here in the scripts, and the script go and look inside the bin folder. If you are using a Windows machine, these bin entries will be a little more complicated. But we saw in this lecture two ways in which we can use our libraries. First of all, we can import it either with CommonJS or with modules. And if this library registers itself in the bin folder, we can directly execute it inside the command line. In this lecture, we will talk about development dependencies. And to answer the question, what are development dependencies? We can ask in another question, like, am I writing this small, stupid, and short program for the Node environment or for the browser? Well, it is just printing a random string. Can it run inside a browser? Let's quickly find out. Let's create an HTML file and try to execute it inside the browser. So here I will just say index.html, and here I will use an abbreviation from VS Code, and let's reference this script inside an HTML file. I will put here a script and just reference this script. Let's see if this works inside a browser. I will open my browser and let's see the console. All right, it tells us, hey, cannot use import statement outside the module. All right, that's no problem. We know how to fix this now. If we go back to our file, let's just convert this into a require. All right, now we are using the require function. Let's see if now it's working. I refresh it. And again, it tells us require is not defined because browsers don't know about this function require. Well, is there a way in which I can execute or use this library that I have imported inside my program inside a web browser? Well, one solution would be to just copy this function from this UUID, from this right here, copy paste it right here inside my JavaScript file, but that of course is not a solution. What can I do to execute this code inside the browser? And the answer is module bundling. That means that we can use a tool or a library which will take all our dependencies, switch it back to import, all our dependencies, and put them inside one file. It will bundle everything inside one file and then the browser will be able to use it. There are many libraries that come with a solution to this problem. They are called module bundlers, and maybe you have heard about Webpack. If you didn't heard about it, you will hear about it when you will work with Angular or with React. Webpack is highly used there. It is a module bundler. But when I want to choose a module bundler, or when I want to choose a library for my Node project, I usually go to a website called NPM Trends. Let's just call this NPM Trends. This website, NPM Trends, it will show us how popular different NPM libraries are. For example, I can see how Angular, React, or Vue compare about them. This website is not without its problems. Currently, it tells us that Vue has become very popular. Well, I don't know if this is true or this is just a bug in the NPM JS registry. But here I can say that Angular is pretty low, React is high, and Vue just skyrocketed. Let me go back and search for Webpack, and I can see how popular it was in the past, in the last year, or maybe even more. Let's look in the last 2 years, and its popularity is growing. But there's another library for bundling which is growing. Also this rollup, it is popular. Parcel, Snowpack, I think it's not so popular anymore. One library that is very popular recently is ESBuild, and as you can see, it is becoming more and more popular. I think the main reason is that it is much more lightweight than Webpack. Webpack is becoming very, very bloated and hard to use, especially if you are a beginner. Alright, so let's install this library and see how we can use it. I will go to my terminal and call npm install ESBuild, and because this is a development dependency, because I'm using it while developing, I will save it as a development dependencies with the flag --, save dev. Let's install it, and you can see now there's a new entry inside our package.json. We have dependencies, but we also have dev dependencies. And as the name suggests, these are dependencies used during the development of our project. They are not used while running our project. And since we are talking about development dependencies, one other type besides module bundlers that are development dependencies are, for example, test frameworks. If I go back to our NPM Trends website, I'm thinking, hey, what would be a nice solution to test my environment? I heard that Jest is popular. Let's see how it is working, how popular Jest is. Again, in the last 2 years, Jest is a very popular development library for testing. And again, here I can see other libraries which are used for testing in this purpose. I can see how it compares to Mocha or with Jasmine. And with this analysis, it is easier for me to make a choice regarding the library I'm using. Here I can see that Jest is a much more popular library, and this will help me make a better choice. So I think we understood in this lecture what are development dependencies. In the next lectures, we will build our project to be able to be run inside a web browser using the ESBuild library. Let's now use ESBuild to bundle our code for it to be able to run inside a web browser. And to do this, we will create a new entry, a new script in our scripts entry in the package.json file. I will call it build. And contrary to your expectations, build is not a built-in script inside Node. This was the case before, but now we need to define it ourselves. So what we want to do now? What we want to do in order to build our project? We will invoke ESBuild because it is an entry inside our bin folder right here. ESBuild. We want to execute the index.js file. This is the entry point of our application. We want to pass the bundle argument, and we want to specify an out file. So here I will say out file, and as a convention, the out file is usually put in a folder called dist, but we can specify anything right here. I will just specify dist. I will say here out.js. Save this, and now let's try to run this. So here I will say npm. So npm build doesn't work. It's not a built-in script. I will call npm run build. And if I don't have any problems right here, I should see a new entry inside my code, a dist folder with this out.js file. And this out.js file combines, let's look at also at our file, combines the v4 from the UUID with our console log. And this out.js file is able to be understood by a web browser. Let's see if this is working. I will reference it inside the index.html. So here the script source will be dist out.js, and let's open this inside a web browser. Let's check the console, and yes, we can see this random string, so it is executed. This way we can execute code from different packages that we get from npm inside a web browser. Just for the sake of argument, let's try to see this string not also in the console, but also in the document. For this, I will just alter a little bit our index.html. Here I will add a h4 entry, an h1 entry, h1, and I will give it an ID. ID is first, let's call it first. And inside our index.js, let's first create a function. So I will call function display random string. I will call it display random string. And let's see, let's make a check in order for us to be sure that we are inside an HTML page. So the simple check that we can do is type of document. If we have a document object, that means that we are running inside a web browser. So here I'll say if we have this document, I will get a reference to the first h4. So I will say const first is document, get element by ID, and let's just call this first. Now that we have this reference, I will just say first and call the inner HTML to be our v4, just like this. All right, let's see if this is working. Oh, forgot an if right here. All right, and finally, let's call this function right here. And again, let's first bundle our code with npm run build. It bundled it again. And now if we refresh our page, we should see this random generated string every time we refresh it. You may wonder if we can call this bundling also for code that we execute inside the Node project. And of course, we can do that. I will create a new entry right here, or because I'm lazy, I will just copy and paste this one. I will call this build browser, and this one build node. And again, we will bundle the same thing. The difference right here is that we will specify the platform to be Node. So here I'll say platform is Node, and the out file will be a common JS file, just for us to be able to be executed. Otherwise, we will get some nasty error. And the same, if we don't specify this platform Node and we will try to execute that code with Node.js, we will get a very misleading error. You can try to check it, what error we get. And because we are at this point where we are building scripts, let's build one more script, call it build all, in which we will just run both scripts. So here I will say npm run, npm build, npm run build browser, and also npm run build node. Let's see if everything is working. First of all, let's check if build node is working. So npm run build node. And again, it created a CGS file. Let's try to execute it. So I will say npm, no, I will say node list.out. All right, it is working. If I'm trying to execute the other file that was bundled for the browser, let's see that you will see that we get a very misleading error. It will tell us that crypto, something like that, is not supported. That's not the case. We need to bundle things for Node in order for them to be executed. Let's clear this. Let's see if our final script is working. For us to see this, I will delete this dist folder. And here I'll say npm run build all. And the two bundles were created right here with one command. As a last note in this section, this may be the first section that is a little more advanced, in which you may be able to run into some real problems. For example, if you don't make this check right here, you will get an error if you try to run this inside Node. Currently, when running inside Node, this is not executed because we don't have a document right here. Also, if you don't configure this the right way, you will get also into all kinds of errors. Some of them can be very misleading. But as you saw, we are able to build and bundle everything the right way. In this lecture, we will talk about global dependencies. And to understand the need for global dependencies and to actually know what global dependencies are, let's look at our small project. Here we have installed our dependencies with UUID, and if we want to execute this, because we configured this in the npm scripts, I can just say npm run UUID and I can execute it with no problem. But if I will change the terminal into another folder, if I try to do the same, of course, this won't be possible because this folder, another folder, is not configured as a node project, and also there's no way it can access this UUID from inside another folder. Well, is there a way I can do that? Yes, it is if I will install this dependency or any dependency which is executable in a global state. Well, the next question before actually installing a global package is, are there any global packages installed, or is there a way I can know what global packages I have installed, since these global packages, I can't just check a package.json file and see what dependencies there are installed. Well, before installing, let's learn about another node command, the listing dependencies command. If I will call here npm list, it will tell me that in this folder these are the dependencies, and this is a great way in which I can see the dependencies. If I will call it with another flag, the depth flag, if I will call it with depth, it will tell me the dependencies and the dependencies of my dependencies. As you can see, this gives me a strange view for my dependencies which don't have any dependencies of their own. Let's clear this. But now let's see if there are any global dependencies installed, if there are any global packages installed. And to see the global packages that are installed, I will call npm list with the -g flag. And let's take a break and think about this. Are there any global packages installed? Even for you, maybe you just installed Node. Are there any global packages installed? And let's find out. I will also run it here. And yes, I can see that I have npm installed. So in the end, npm itself, it's a package and it's a global package. And there's a very interesting read you may find on the npmjs.com website. If you search for npm, there's a very interesting read about npm. As you can see, it is itself a node package. And there's one very nice trivia at the end of this part. Well, enough talking. Let's see how we can install a global package. Let's start with this UUID. I can just say npm install, or just it is the same UUID. And if I want to install it as a global dependency, I will pass the flag -g. And because I'm on Linux, this won't work, because I need to give it permissions to run this globally. So once again, I need to call this with sudo, just on Linux. Alright, I have installed this, and now if I'm going into another package or into another folder, I can just call this UUID. And as you can see, this executes even if I'm in a folder which doesn't have a package.json file or any node modules. Let me talk about a very short note if you are running on Windows. If you go to your system properties, in order to be able to execute global node packages, you need to register node as a environment variables. So if you are on Windows, you can go to your system properties, you can go to your environment variables, and there you have the path right here at system variables. If I edit this, you should have an entry with your path to your Node.js installation. If you have this, you will be able to execute global node packages. If not, you won't be able. So if you don't have this, you can just add a new entry right here and pass the path to your Node.js installation. Let's go back to the IDE. Alright, we have installed this. If now I will list my global dependencies, you will see that I also have this UUID as a global dependency. One other command that we can check is, hey, if they are installed, where are they installed? And if I want to know where in my system the global packages are installed, I can just call npm root, again with the G flag. And this will tell me, hey, this is the path where your global packages are installed. The last point I want to make in this lecture is try to answer the question, when should I install a dependency as a global dependency or as a global package? Well, there's not a clear answer to this question. Usually I tell you what I do when you want, so they are available from anywhere inside your system. Usually that's you don't need this, but I sometimes try it when I'm learning a new technology or a new package. For example, everybody is crazy now about TypeScript. So when I learned TypeScript, I installed it as a global dependency, and then I used it wherever I was inside my computer. So if I try to install TypeScript and install it as a global dependency, alright, it has installed. TypeScript doesn't install like this. Now if I want to see it, it doesn't register with the name TypeScript. It registered with TSC. So now I can just see TSC minus version. And you can see I have installed globally TypeScript version 4.9.4. So we saw in this lecture first what global dependencies are and how we can install them. Also, we saw how we can list our packages or how we can find out where global packages are installed. Let's now talk about versioning in Node.js, or semantic versioning, or semver. It is such a big word, but in reality things are fairly simple. Well, we are talking about versions, and as you can see, each package that we install, and even our own package, it by default needs to have a version. As you can see, it is consisted of 3 numbers. For us is 1.0.0. And what does these 3 numbers mean? First of all, let's start from the end. The last number means this is the patch version. This means that if I would increase this version, every time I would increase this version, I would introduce some bug fixes. I will do a bug fix and I will update this patch version. If I would increase this version, this is the minor version. This means that I would introduce new features inside my package, but I wouldn't break anything. The latest one is the major version. If I would increase the version of my package to, for example, 2, this means that I would introduce some breaking changes. That means that anyone who uses my package should expect differences in the way it behaves, and he should update the way he uses this package. This in the end is the talk about versions. Let me change this back. Let's look at the packages that we have installed. And as you can see, we have the dependencies UUID and ESBuild. But there are not just 3 numbers right here, there are also these characters right here. This is the caret indicator. This means that, and this is the default way NPM installs packages, this means that anytime a minor version will be released, like 9.1 or 9.2, and I will call npm install, npm will install the latest stable version, which is minor. Maybe I'm confusing you right here, but let's check this out. There's another way I can call this, for example, with the greater than symbol, this one right here. And let's check this. What will happen if I'm instructing package.json to use this version? This means that Node or npm will install the latest stable version, which is bigger or greater than version 8. And to check this, let's delete these node modules, save the package.json file that we changed, and call npm install, and see what happens. If I check the node modules at UUID, you will see that it still installed version 9 because it is the latest stable version that is bigger than 8. I could also have here a tilde character. Let's see how this is working. This means that it will install the latest patch version that is greater than 8. Let's see how this behaves. Delete this and try again. npm install. Let's see again what it installed. Now it installed only version 8 because it doesn't have any newer patch version that is stable. So node versioning is something that you can play around with and see how it behaves. There are also some keywords that we can use when installing a version, a package. For example, if here I will call latest, save this, clear this. I want to see what happens if I call the latest version of UUID, and I also deleted the node modules and the package log.json file, and call npm install. Let's see what happens now. As you can see, it installed the latest version, the latest stable version. So if I specify right here the latest, means the latest stable version. There's another keyword I can put here, the star. This means that it will install the very, very latest version, regardless if it is stable or not. Because sometimes packages may be like this, but they can also be like this: alpha 1, alpha 2, or release candidate 1, release candidate 2. These are unstable versions by convention. And if I will, in my package.json, I will specify, hey, install the very, very latest version, it will install it no matter what, no matter if it is stable or not. Again, all that we talked in this lecture are just conventions. For example, I've seen many times when I update a patch version or a minor version, there in theory should not be any problems, but in practice, every time you update a dependency, you should make sure that nothing breaks. For example, we can check how different packages work. If we look at this ESBuild library, it's still at major version 0. This means that it's still not ready to be used in production, but I've been using it for 2 years now, and it worked just fine. So in the end, this is just a matter of preference from the developer. One package that I found very interesting is, for example, the AWS SDK. If I try to install it, AWS SDK, you will see something interesting about it. You will see that it is at version 2, so it's okay, but the minor version for it, at least at the time I'm showing you this, it's 1281. So even if it's version 2, they always introduce new, very small features. One last note in our lecture: sometimes we would like to install a specific version of a package. So let me clear this and see what I mean. We can try to again install the AWS SDK, or you can try to install any package you like. But if we want to specify a certain version, I can just say here at and then specify the version. For example, 2.1280.0. Let's see if this version even exists. Alright, it exists and it installed this specific version. This way, this approach of installing a certain version of a package is useful, especially when you are trying to update global packages and you don't have easy access to their package.json. So, for example, if I want to update our npm installation, I can call npm install globally with sudo npm, and I want the latest version. So here I can say npm at latest without spaces right here. Alright, and as you can see, this way I updated or installed the latest version of npm. In this lecture, we will see another way in which we can execute code that we get from Node.js packages. Until now, we were executing our code that we got from Node.js packages if we put them inside our Node module as a dependency, and then we configured a script. Currently, I can call npm run uuid if I'm in this folder, and this will be executed. Let me just add an echo right here to make sure that we are executing the right thing. You will see in a moment. So here I will pass echo. Let's execute this one more time. And now you will see we have this script that is executed. But what happens if I want to run this from anywhere inside my application? Well, the answer is simple, because this UUID is a global package. If I will list my packages, npm list my global packages, you will see that I have UUID installed. So even if I change the directory in a place where there's no node package or node project initialized, if I call UUID, I will still be able to execute this code. But let's delete this UUID global package with npm uninstall and globally this UUID with a sudo. Alright, and now if I want to call here npm run UUID, of course this is not an npm project and UUID is nowhere to be found. Well, finally we can see the point of this lecture, and I want to talk about NPX, which stands for Node Project Execute or something like that, and it is a way in which we can execute any package from the internet. So pay much attention right here. NPX is a tool that comes installed with Node. So if you installed Node, you should also have NPX installed. So if I want to execute this, I will just call npx and the name of my package. It will call the latest version and execute it. The same can be said also for, instead of npx, newer versions of npx use npm exec. So npm exec is a command that works outside any npm project, so I can use it. Unlike npm run, if I call npm exec, I can run it from anywhere. Again, I can call this, and it's the same. It will download a local copy of this package and execute it, and after some time, of course, it will be deleted. This way we don't have a lot of global packages installed, packages that we only want to run once. And I think the most popular example right here is with create React app. So if we will just focus on this terminal, let's just look at this terminal and try to run npx create React app. It's a tool that initializes a starter React app. Create React app is a big package, so this way I can just run it once and forget about it. I can call npx create React app and of course give a name to my app, my sample app. I will call this, and of course first time it will ask me if I want to download this package as a local cache. I will call OK. Alright, finally my React application is initialized and I did this with npx. Let's now talk about peer dependencies. And I was exploring the project that was created in the last lecture. And as you can see, we have a dependency to React and to React DOM. Let's check this React DOM. Let's check its package.json. In the node modules, I will navigate to React DOM, the package right here. I found it. And if I check its package.json, you will see that it has an entry called peer dependencies. And it requires a dependency of React and with this specific version. Well, what are peer dependencies and what is the difference between peer dependencies and regular dependencies? For this, I created a small drawing in which I'm trying to explain what are peer dependencies. Let's say that on top of React, we want to build different plugins. For example, React DOM is a plugin or an extension to React or something built upon React. In the same time, in React, we can have different components that still work with React. We have a custom component 1, custom component 2. Well, why would React be required as a peer dependency to these packages? Let's go down and let's say that we want to build a very awesome application that requires React, React DOM, and other custom components. Well, can you spot the problem right here? We have an application which has a reference to React, and also it needs React DOM, which also needs React. It needs a custom component 1, which also needs React, and so on, so on. As you can see, all these dependencies will require React on their own, but React will already be installed. The cleanest way would be to specify React right here as a peer dependency. This is the whole point of peer dependencies. They are used inside plugins, which are meant to be working alongside a bigger package. If we would install, for example, React DOM in a project that doesn't have a dependency to React, let's try this. So I will open our other project, which doesn't have a reference to React. In this project, if I will want to install React DOM, it added this React, but it also did something else. If we check our node modules, because we have installed React DOM, you will see that we also have installed React. And this is a big change, a big recent change in the way NPM works, because before version 7 of NPM, whenever you will install a package that requires a peer dependency that is not installed, you will get this kind of warnings. And you will, if you search Stack Overflow, you will see that these kind of questions are very popular. You know, the warning that a package requires a peer dependency of other package. Now with the newer versions of NPM, peer dependencies are also installed alongside dependencies. With peer dependencies, maybe you won't be building them so often, but be sure that you will debug them sometimes, because they sometimes come into conflict with one another and you will have to choose what peer dependency you work on. When your app will be finished, you will want to ship it to production, to an environment which you control and in which you want to know exactly what is happening. Well, if you want to control everything, then npm install is not a good solution, because when you hit npm install inside the node project, using the same package.json file may lead to other results depending on your time. For example, we have these simple dependencies right here, but npm install is not deterministic, because maybe 3 months from now it will bring us other versions of our packages. Because we use this caret right here, it might bring another versions of the packages. That's why when you hit npm install, a package lock.json file is created. We talked before in this course about it. Now we will take this discussion. We will resume this discussion about package lock.json file, and you know that we can use it, and it will be used in a deterministic way by a command called npm clean install. And this is the type of command you want to use when you will ship to production. So there are many differences between npm install and npm clean install, or CI for short. npm clean install will reinstall your node modules to make sure that it comes fresh. Also, npm clean install will check both your package.json file and also your package lock.json file, and it will use exactly as it is. For example, I can hit npm clean install and it will install the dependencies exactly as they are specified in the package lock.json file, but it will also check for the versions. For example, if I'm making a change right here which is not compatible with package lock.json file, if I hit again npm clean install, I will get an error because it will tell me these requirements are not met. You may use npm clean install when you are preparing a test environment in which you want to control everything to make sure that your code is executed the right way, and also maybe when you will ship to production. And talking about production, we talked about this npm clean install, but maybe sometimes you will ship to production, and of course you want to ship to production only your dependencies, not your development dependencies, which for many packages are much more bigger than the dependencies itself. How can you install only your dependencies, not your development dependencies? Well, if I will delete our node modules, and if I will run npm install with the flag omit, and I want to omit the development dependencies, I will specify omit dev. Then it will only install our dependencies, and as you can see, esbuild is not right here. Let's install everything. Maybe sometimes in your pipelines you will want to install everything, even your development dependencies, but then at some point you will want to remove the development dependencies. There's another command that we might use, is called npm prune, and this command can remove certain packages. For example, if I run npm prune with the production flag, it will only keep inside our node modules only our dependencies, not our dev dependencies. So if I hit npm prune right now, it should remove esbuild. Let's see. Let's refresh this folder, and yes, it removed this esbuild development dependency. So in this lecture, we saw a few tweaks in which we can prepare our package for development inside a test environment or to production. There's one last point in which I want to make. While talking to development for production, if you ship your application alongside your node modules, then you need to be very careful where you put your dependencies and your development dependencies. You may put your esbuild inside your dependencies, but if you are using bundling, for example, and you will ship to production only one file, only one bundled file, then it really doesn't matter if your dependencies are dev dependencies or dependencies, because in the end one bundle will be shipped. In this lecture, we will see how we can check the outdated packages inside our project and also how we can easily update them. And to demonstrate this a little easier, as a demonstration, I'm using a React project, which I generated 3 years ago, so it is pretty outdated. The most direct way in which you can know that a package you are using is outdated is if you are checking the package.json file, you are looking at the dependencies. If we hover over a dependency, VS Code will show us its latest version, so we can make an idea of how outdated this package is. Well, let's call npm install in this old project and see what happens. It will be interesting. I will call npm install right here and let's check the console. It will first tell us that this is a old version of a log file. It will update it, so it will regenerate it. Well, the installation is finally over. There are lots of changes and lots of warnings right here. We also have security warnings. We will talk in detail about them in the security section of the course. But now that we have installed this, we can call the command npm outdated, and this will list the outdated packages inside our project. You see, we are getting some results right here. For example, we have installed React 16.12. Here we have a column with the wanted entry, and this means that this is the version that the semantic versioning permits to be installed. We have chosen the caret right here, which means that this can be updated up to the minor version. The latest minor version is 16.14.0, and also this npm outdated command will show us the latest version of this particular package. Well, is there a way I can update all of them in one command? Of course, if I call the command npm update. But if I call it only like this, I can call it only with a certain dependency, but I find it easier to just call it for all the dependencies if I don't specify one. But if I call it like this, it will only update the package log file and also the node modules. But I want to see this change reflected also in the package.json file. So I will call it with the save flag. If I call this, the command is over, and as you can see, these updates are reflected also in the package.json file. If we will compare this, you can see that it updated all the packages up to the minor version. So this was a way in which we can list all the outdated packages with npm updated, and also we can update them with npm update. We will now talk about npm workspaces, and to understand what they are and why we need them, let's first talk about a way in which code can be organized called monorepos. I've made a very simple drawing. Usually applications or small projects are put into different categories. For example, we might have a server project with its node modules and its package.json and its implementation, and a client that uses this server project, which imports the server project and uses its functionality. Well, what are monorepos? Monorepos are a way in which we can organize our code into one bigger code base or of packages which are related to one another. Monorepos are very popular at Google. You may search for monorepos and learn more about them. The point is very simple. In a monorepo, we have only one folder that contains the node modules and the dependencies of both projects or other projects. And then we have each project with its own implementation and its own dependencies, but which stay in one node modules folder. This is the implementation that NodeJS and NPM brings to the table with a new functionality, or its newer functionality, called NPM Workspaces. Let's now explore this. So I've started a brand new project. I'm in the same folder. I'm just using a different Git branch. You may create a new empty folder on your computer. Let's first initialize an npm project right here. I will call npm init, and with the flag I, because nobody has the time to answer all these questions, I will clear this. Now we have a package.json file, nothing new until now. I just have this Git integration right here. Okay, what I want to introduce now is the workspaces. So I could just simply write here workspaces and populate this right here. But a simple solution would be to use the npm CLI. So I will still call npm init -y, but this time let's focus on the terminal. npm init -y, and I will pass here the -w flag, which stands for workspaces, and I will want two workspaces in a package folder. I will call here workspaces packages/server, and again another workspace in packages/client. Call this. Let's explore this, and as you can see, now we have two packages, and now we have an entry in our main package.json file which consists of workspaces, and as you can see, we have a workspace with packages server and packages client. Let's explore this right here, and as you can see, we have a packages server and a packages client, each one of them with its own package.json file. We also have some node modules. If you don't have them, let's just first call npm install, and this will create our node modules. They are very interesting. If we check them, you will see that we have these two entries, client and server, and again VS Code indicates that they are symbolic links, which means that anything that changes inside these packages will be directly reflected in the node modules. Why is this very important? Well, we said in the beginning that our client will import our server, or will use functionality from the server. Let's create something very quick in order to understand what I mean. I will create a new file in the server, call it index.js, and here let's just export a very basic function. So I will say module exports, and let's just make a very simple function right here, which just prints hello from server. All right, save this, and let's add a dependency to our client in the server package.json. So if I go to the package.json of our client, now we want to use the server inside the client. Here I will have the dependencies. Let's add dependencies right here. And here let's add the dependency to a server, and let's call this with the latest version. Save this. Again, call npm install. All right. And now in our client, let's create also a file right here. I will call index.js. Let's make a console log right here. Console log, and I will call this inside the client, and let's now import our functionality from the server. So here I will say const server, and we call the require, and we will require our server. Let's see if our server is working. So let's call this function server, and let's now try to run it. So inside our folder, I am still in the npm practice folder. I will call node, and let's go into packages, into the client folder, and here call the index.js file. Okay, I have a small problem. All right, so I had a typo in the way I was calling this function. Is with packages, of course. And now if I'm executing this client code, you will see we are inside the client, but we are referencing the code exactly from the server. If I'm going to the server and I'm modifying this file, I will call here update, save, and execute the client again. I didn't call any npm install or something. You will see that the code automatically updates. This is very convenient, and this is possible because inside the Node modules, we are using symbolic links. So we saw until now how we can reference things around reference code using NPM workspaces. Let's close everything and let's talk about something else. Inside the package.json, we have an entry with the scripts. And usually all the commands that we learned until now in this course are also valid for certain workspaces. If, for example, we want to call the test, I will call here npm test, and it will execute the npm test from the main package.json. But in the same time, we have a package.json in each package. So here, if I will maybe change this, we are in the server, so I will call here test server and without the exit one. And in the client, I will call here again test client. I can again call the test commands from our packages. Save everything and call npm test, but this time with the flag ws, which stands for workspaces. And as you can see, now this command will call our test commands inside our packages. If I want to, for example, call only a command inside a certain package, I will call npm test and I will specify the workspace. So the workspace with -w is our packages / client, for example. And this will only invoke the test inside our client. Inside our project, I can also install different libraries. I can install a library for testing, maybe Jest. I can call npm install Jest, and this will install a library, and our node modules will not be so clean. I can install this library, and I can use it inside our different packages. I have installed Jest, and now in our client, if I want to use Jest, here I will say Jest. Then of course, if I will now want to test the Jest, the client, and I will call this, I will get the Jest error that of course our packages, our test is not configured, but hey, it executes Jest code. Again, if I want to install a package only for one workspace, I can call npm install. For example, maybe in the server I want to use Mocha. I don't want to use Jest, and I want to use Mocha only for the server. I can call npm install Mocha, and I can specify the workspace. So -w packages server. Install this. This is called a filtered install. And now if I'm expecting the package JSON from our server, you will see that it now has a dependency to Mocha. Let's check a final note and regarding the naming inside our project. We saw before that we can see what is outdated inside our project. So I can call npm outdated, and let's see what is it outdated inside our client. So here I will say npm outdated in the workspace packages client. And we will see something pretty interesting. We have the package server, which is current at version 1, because this is the way we configured. But it says that its latest version is 1.0.38. Well, this is wrong, because this npm outdated will directly check the npm registry. It currently doesn't check npm workspaces. Even with VS Code, if I'm checking the package JSON inside the client, and I'm looking at our dependencies, even if I'm referencing a local dependency, it will tell me that I'm using a server.js library like this. So a better way would be to properly name our packages and not give them so generic names. Maybe I will give a name right here and I will call it at npm practice, maybe npm practice / client or something like this, and do the same inside the server. Maybe update their names, and this way there won't be any name collisions. So we saw in this lecture how to use npm workspaces. They are very complex, but you should keep in mind that any npm command that works inside the Node project works also inside the Node workspace. In this lecture, we will build the very small and basic library that we will export and then publish. I will call it, it will be a logger, and I'd called it concise logger. The name is not taken on npm. So this is an empty folder on my computer, and I started VS Code inside it. Here we are. Let's now initialize this as a Node project, npm init -y, just like we did before. And now I will create a new file which will contain our functionality. So it will be in the source folder, and I will call it logger.js. It will be a logger. So here I will say export class logger. Let's build above it a function that we won't export, the function that will really log. So here I will say function log, and this will get two arguments, a level and a message. And here we will use the process function because it uses a lot less memory. So here I will say process std out, and here we are calling the write method. And let's now print what we get. First of all, we want to print the level. So here we will print the level. And then we will print the message. And then we should add an empty line at the end with \n. This is our base function. And let's now build three function, a debug function, which gets a message. And here we will use our function, and we will call this with a debug argument and our message. All right, let's copy this and let's call this info. We are changing just the level and then the error. All right, this is our very basic class. Let's quickly test it. And because I'm using export, you know that we need here to specify a type to use modules. Let's quickly see if this is working. So I will create a new test class, call this test.js, and here we will import our logger. Very important, when you are doing these imports, make sure that you are specifying the file. Otherwise, you will get errors and you will get stuck because they are misleading. So here I will say import our logger, and let's check if this is working. I will say new logger and call the, all right, we don't have the error. Yes, here we say error, just error. All right. And now we want to, let's just print an info. Here is an info. Let's see if this is working very fast with Node. So here I'll say Node test.js, and yes, I have a typo somewhere. Yes, here it's std out. Let's try it one more time. Our packaging is working, so let's see in the next lecture a very direct way in which we can import it locally without publishing it. We've got our simple package, but there is still one very important step that we need to make in order for it to be usable outside its own scope. Let's close all this. And in the package.json, you see we have an entry. We haven't talked too much about it until now. The main entry, which is called index points to index.js. And I find this as a good practice to use this main index.js to export everything from your project inside one file. What do I mean by this? Let's create this file. And in this file, I will call export, and let's just call this logger. And now we are exporting our base class, our logger, from our logger.js. Inside this index.js, that is the main entry of our module. Let's save this. Save everything. And in order to try this, let's initialize yet another test package, which will use this library. So I will go to my file explorer, create one more folder. Let's just call this local package test. And again, open VS Code inside it. We did this a lot of times. npm init -y. We have a package.json file, and now comes the very interesting part. We can install a package directly from the local storage. How we can do this? Very easy. We go to our package, we select any file from inside it, VS Code assists us with it, and let's copy its path. We need its path. Let's now go to our add other window, and let's just simply call npm install and our path. And here we need to path at the path at the folder level. So this is the path. For you it might be different, but remember, at folder level. I will hit enter, and as you can see, now we have a new entry in this package.json file called dependencies, and it's invoking the package name, but it doesn't have a version right here. It just points to a file. Very interesting. If we go to our node modules, you can see it directly went into our node modules. These early steps in the development or different packages are a great way in which you can check, for example, the package log.json files and try to understand better how this works. As you can see, currently this is a very simple file, and because it is a local file, it doesn't point to any npm registries. This was a parenthesis. We are closing now. Let's now use this package. So let's just create a new file right here. Let's just call it test.js. And here we will import our logger. And here we are importing our logger. VS Code gives us some warnings because it can't find, let me hover over it, because it doesn't find a declaration file about this concise logger. And it would like to have some types for this concise logger. We will talk in detail about this adding types to our libraries in the next section, where we will talk about NPM with TypeScript. Let's now use this library. Simple new logger dot debug. Let's try it. This is a debug. Let's see if this is working. Node test.js. And yes, because we are using modules, we need to specify this. Type module. One more time. Yes, we can use this package locally, even if we didn't publish it first. This is a great way when you are developing different packages to have a quick feedback on your development without first publishing. And if we are using a publish functionality, if you want to change something, you will need to update the version. So it's kind of hard to do this in the early stages. This is a great way to test the development of your packages in the early stages. You can just install it from a local folder and you can have almost instant feedback on your development. In the next lectures, we will see how exactly we can publish our packages to a private repository. Until now, npm.js was the only place in which we would resolve and search npm packages. But did you know that we can also find npm packages on other places on the internet? And what I'm talking about are private registries, npm registries. Well, npm, it's a public registry, but for example, if you are working as a Node.js developer or you want to work as a Node.js developer, most likely in your company, you will work with a private npm registry because you will want to use the company's internal packages, which are not public, they belong to the company. Also, working with a private registry will help you understand better how these registries work under the hood. This is what we will do in this lecture. Let's get started. First of all, let's see what happens when we call npm install. So any package we are installing, npm will by default resolve to a certain registry. If I call the command npm get registry, you'll see this registry.npm.npmjs.org. This is the default registry that npm comes configured with. We will change this in this lecture. And we will also install a private registry. We will do this very easy. We will use a package called Verdaccio. I guess this is the way we pronounce it. As you can see, it is also pretty popular on GitHub. And this is a private proxy registry. This means that we will initialize our own registry locally. How we can do this? This is very simple. We can install this package as a global dependency. I will just copy this command right here and install it locally. Let's see. I want to make sure that I am in my logger project. It doesn't really matter. Let's paste this command and install globally this Verdaccio. Yes, I need a sudo right here. All right, this library installed. Now we can just execute it, or we can start this registry with the command Verdaccio. Or even better, let's start it in another terminal. I will call in a separate terminal this command. Okay, and as you can see, it instantiated itself at this address, and this is very important. This is our private registry. Let's open this address in the browser. And as you can see, this is how the basic view of a private registry. I'm making it dark. Let's now create a user and start to use this registry. So the first step it would be is to just create a user into this registry. So I will copy this command. It already tells us. Currently for me it won't work. I'm getting this error, web login not supported. I don't know exactly why this is happening, but maybe for you it will work, or by the time you are watching this will be resolved. But if you are still getting the same error as I do, we can add the flag of type legacy, and this should work. Alright, and now I can configure a username and a password. I will just add my username and a basic password. And I'm now logged into this private registry. How can I check this? With the command npm who am I. Alright, I'm currently not logged in the default registry, but if I will pass this registry right here, the one that we configured, copy, and I will call again npm who am I with our registry, you'll see that I'm logged inside this registry with my user. Let's now publish our package to this registry. So I will clear this terminal and I'm currently in our concise logger package right here. Let's publish this package. And even our localhost now, our Verdaccio page, shows us what we can do to publish. This is the command right here. I will execute this because we are calling npm publish, and anything we do with this registry, we need to be specific. I published this. Let's see if we can see this inside the registry. So I will log in again with the credentials I just configured. And as you can see, we have this concise logger package. Currently, it says that it is published by unknown. I guess this is related to the login problems that I had before. This is the one. I didn't provide any README, so it didn't put it right here. But we have a initial version, and if we want, we can download it directly from here. But of course, what we want to do is to install it in a different Node project. This is what we will do. So I will go to our other project, our local package test right here. I will delete its node modules, its package log.json file, and inside the package log, I will delete the reference to our dependencies. All right, and let's now install here from our private registry our package. Again, first we need to check that we are logged in. So I will call npm who am I, and with our registry. All right, we are still logged in. That means that we can install our private package. npm install concise logger. All right, and by default, it looks at the npm.js registry. So we need to specify our private registry. And yes, finally, if we are specifying our private registry, you will see that we have now our dependency to our concise logger. Hopefully everything still works as it should. Let's see. Node test.js, and yes, now it's executing the code that it got from the private registry. One last point in our project. I'm still back in our concise logger library. And we want to work with this project always to deploy it to a private registry. One way it would be to just publish it and specifying the registry. An easier way would be to call the npm set registry command. So I'll call npm set registry and specify our registry. And this command will do something interesting. It will create a file called .npmrc. This file contains different options or different configurations regarding to npm, which are different from the defaults. Currently, this file informs npm that it will use inside this package a different registry when publishing. One more point, we can publish again, but in order to publish, we need now to change the version. Otherwise, we won't be able to publish. I will save this and call npm publish. And now our package is published to our private registry. And let's check it if I'm refreshing this. Now we will see that we have two versions inside of this package. So this was a brief introduction to how npm registries work, how private registries work, and how we can access them. In this lecture, we will migrate our very small package to TypeScript. And I'm talking about our concise logger package. Let's get started. The first step that we need to take is to install TypeScript. We have it installed locally, globally. If I call npm list -g, we have installed TypeScript, but let's install it also locally. So here I'll say npm install, and I want it as a dev dependency, TypeScript. All right, we have it as a dev dependency. We can see this in the package.json file. The next step would be to create or to initialize this project as a TypeScript project. And to do this, we need to call the TypeScript compiler. I strongly suggest you to also have TypeScript globally installed. This way we can call different commands very easy. I will call now tsc --init, and this will create a TypeScript config file. I will open it and I will pause the video and remove the comments. This is the default tsconfig.json file. Let's also add some little tweaks. First of all, we need a lib entry, and here I will just specify ES6. And notice this module entry, common.js. This means that the files that will be generated by the TypeScript compiler will be in common.js form. This also means that we will need to modify our project, our package.json, to match this common.js. It doesn't really matter, we will still be able to use import-export syntax, but this is more convenient because common.js files are more wider supported. So also in the package.json file, I will change this entry to type common.js right here. We also need an include entry. So here I will call include, and here we need to specify our source directory. All right, now let's change our logger.js to logger.ts. Okay, and also change this test file to ts. And what's the problem? Yes, we also get all the errors from the TypeScript compiler. Let's add this some types to this file. So first of all, we need some typings to our level and message. But what I want to show you, very important, is that this error that we get on the process. It will tell us that it can't find the name process. This is one of the first steps that we need to make when you are working with TypeScript and with Node. You need to install the Node types. Let's do this. So I will copy this command and call it in the terminal. And now if we look at our package.json, you will see that we have an entry at types node. And yes, this is what we installed. Let's check our node modules now. And as you can see, we have, of course, the TypeScript library that we just installed. We have the bin folder that we talked before, but we also have a new entry right here, a new folder called @types. And this contains type declarations for all the node functions that we use. Currently, you see these type declarations are in the form of the file .d.ts, and these kinds of files only contain types or types declarations. All right, this is an important point because we will also generate these kinds of files. But now let's quickly get rid of these errors. I will add some types right here. And just because we are working with TypeScript, I will create a type to contain these debug, info, or error entries. So here I will say type level is either debug or info or error. All right, this level is of type level, and our message is of type string. Okay, let's add these type entries right here. And everything should be all right. If now I'm having a typo right here, I will get an error. This is the beauty of TypeScript. Everything all right until now. Let's now see if our setup is working at this point. So let's try to execute this test.ts. Also, we need to specify our out directory. So here I will specify our out directory. Very important. This will be a dist. We can specify any name for the generated files, but call this dist. And of course, our root directory is src. All right. There's two ways in which we can execute TypeScript files. One is directly with Node. One is compiling them and then executing them with Node. And the other is with a library called tsnode. Let's first of all compile this. So let's just call the TypeScript compiler and let's see if it works. Yes, we have the dist folder and we have our logger.js. I will move this test file inside the src. Okay, and let's see if I will update the imports. Okay, call this tsc again. All right, we have a problem with the import. It's not JS anymore. Okay, and let's now call ts. Let's now call this test.js. So here I'll say node dist test.js. And yes, we have an entry right here. And to make things more interesting, let's once again use an external library and see how it behaves or how it interacts with TypeScript. And of course, I'm talking about our famous UUID library. I will also install this library right here and use it. npm install UUID. And let's use it inside our logger file. I will create one more entry right here and call this log with ID. And right here, let's say that this will be an info. And let's put an ID also inside the message. So I will specify here. Let's see if automatic imports work. No, they don't. So I will import first this library. And we are getting once again an interesting error. It tells us that it can't find the declaration file for this module. And VS Code kindly suggests us to install these types for UUID. They are not contained in the types for Node, so we need to install it. This is the command that you need to run. I will just press here quick fix and VS Code will call this command for me. Once again, checking the package.json file, and again we have these types for UUID. Now I can call them inside our logger, and I will call the v4 command. Let's now call it right here, v4, and then let's call our message. Let's try to compile once again and see if it's working. Maybe let's put here, let's call this log with ID, and let's see, call this. Do I have an ID? Let's see if this is working. Compile and run once again. And yes, our external library is called. There's one more thing I want to show you before finishing this lecture. We talked about type declarations. Again, if we check our Node modules, you will see that in the types entry, we will now have an entry for UUID. And these type entries come from one singular repository. If I will open this package.json file, you will see that it comes from this definitely typed repository. I will even open it. If I go to package.json file and I will hover over the types of UUID, I will just click and open this link. And you will see these huge repositories with types for all kinds of libraries. Each TypeScript library can have its own types contained within its own implementation, or it can have its types configured in this definitely type repository. This UUID has its types inside this definitely type library, but for our implementation, we will define our own types in the next lecture. As we can see, Node has its types generated. The UUID library has its types generated. Let's also generate types for our own library. The first step to do this is in our tsconfig.json file. Here we will inform TypeScript that we also want type declaration files to be generated. For this, we will call the entry declaration, and we will make this true. Now, if we call the compiler with tsc, you will see there are some new entries inside the dist folder. We will have the logger.d.ts entry, and you will see this is a type declaration. It contains the declaration for our class. You will see this declare keyword, this TypeScript keyword, which contains the method signatures. For example, this tells us the method names, its arguments, and what it returns. If I will want to add an implementation right here, I will get an error. It will say that an implementation cannot be declared in an ambient context. Okay, this means this file only contains declarations, as I said, and the actual implementation is contained in this logger.js file. Well, when do we want to use these .d.ts files, these declaration files? Well, when we will install and use this library outside this package, TypeScript can use this library to get more information about the types required by itself. So, we also need to inform package.json file in the package.json file that we are using these types if we want Node to use them and ship them. We need to make also some changes right here because now our main entry is in the dist folder and logger.js. So here I will change this to dist/logger.js because we are talking about the transpiled file. And also we want to add the types entry. And here we are saying about dist/logger.d.ts. So we configured our types. Well, with these changes, is our library ready to be used outside itself, so to be used as a module by other packages? Well, let's answer this question in the next lecture. Let's now see if our library is ready to be shipped. And in order to do this, we will call the command npm pack, which will generate a archive which will contain our package. So I will call npm pack, and this will contain our package followed by its version. Let's explore it. So if I open this archive, you will see that it contains much more that we need. What we need is contained inside the dist folder. We need the logger.js, our actual implementation, and logger.d.ts, our type declarations. But our package also contains the src folder with TypeScript files, which are not useful in this context. Also, it contains the tsconfig.json file, which is also not required. Well, what can we do in order to ship only what we want? We can create a npm ignore file, which works similar as a git ignore file. So let's create a new file. I will call it .npm ignore. And here we will put what we don't want to be shipped to inside our package. So of course, we don't want our node modules. I think this is by default ignored by npm, but you can't never be sure. We don't want the src folder. We don't want the git ignore file. We of course don't want the tsconfig.json file. And inside the dist folder, we don't want the test.js and test.d.ts files. These are just for our local testing. So here I will say dist/test.d.ts and this/test.js. We don't want this inside our package. Well, let's call this one more time. I will delete this archive and call npm pack one more time. Let's explore it once again. As you can see, now it only contains our package.json file, and inside the dist folder, it only contains our logger implementation and our type declaration. This means that it contains exactly as it should. Let's do a final check and publish it and then use it. So I will call npm publish, and if you remember, I configured a local npm registry in the last section. Let's see if I'm still logged in. I will call npm who am I with the registry that is configured locally. Yes, I'm still logged in, which means that I can publish. But before publishing, once again, I need to change the version. Otherwise, I will get some nasty conflict. Well, let's call npm publish and with this registry. Let's see if it is present into our repository. So if I will go to our concise logger inside our npm registry, you will see we have these dependencies right here, and let's use them locally. So I will go in yet another package, in a package which we called before. Let's update the version right here. Let's use the version 1.0.3 and call npm install. Yes, we need to specify the registry. All right, and let's check our node modules right now, and let's see what it's contained inside them. We have our concise logger library, and inside its dist, it has the logger.d.ts and the logger.js. Okay, this is an artifact that, yes, I should have deleted before. Let's see if we can use it. Again, if I'm looking at this import, you will see if I click on it with Control and click, it will directly open its type declarations right here. And let's do a final check. Let's see if this is working. Yes, our file works again, and this is great because this comes from a TypeScript package. One of the greatest tools that NPM gives us regarding security is NPM audit. And to demonstrate how this tool works, I will open my very old React application, which is at this time 3 years old. I will clone this repository and open it inside my editor. And the first time you will see NPM audit in action is when you will hit npm install. I will call npm install in this old repository and pause the video. Alright, npm install is done, and as you can see, it hit npm audit. It found 86 vulnerabilities, a lot of them high, a lot of them critical. Let's find out more about these vulnerabilities, and I will call npm audit to see some details. And the npm audit view is updated now. It shows a lot more details in what it finds. As you can see, it now lists every vulnerability issue on its level, and it gives us some information about what is actually wrong. If you want to know more about these vulnerabilities, it also gives us a GitHub link in which it offers more details. For example, here we have a critical issue from URL parse, and from experience I saw that most critical issues comes from parsing libraries. If we open this link, you will see how exactly this vulnerability behaves and what can be done in order for it to be fixed. The most easy way in which we can fix NPM vulnerabilities is by using the latest versions of our packages. Let's now call npm audit fix and see what happens. Well, there's some little progress right here, but it still found some important vulnerabilities. What npm audit fix did was update the dependencies of our dependencies. If we look at the GitHub diff, what happened in this project, you will see that it only changed the package lock.json file. It didn't touch the package.json. So if we want to fix all our vulnerabilities, we need to call npm audit fix and with force. And what this will do, it will also update the major versions of our dependencies. Let's see it in action. Let's call this with the force flag and see what happens. Well, we are rid of most of our vulnerabilities. There are 6 high severity vulnerability left. Well, that's reasonable. To fix this, we need to go package by package and see what exactly we can update. But what audit npm audit fix force did was update the versions of our package. And as you can see in React scripts, it updated the major version of this package. So this is what the force flag does. And also we can make an idea of how many vulnerabilities are in old packages. The best way to keep you away from vulnerabilities is to use the latest versions of different packages. So npm audit is a great tool to show us what exactly is wrong with our packages. Sometimes this audit fix and even with the force flag doesn't work really well, and is your job to keep your package up to date and clear of any vulnerabilities. We will now talk about a source of many security problems which appeared in the Node environment, and that is the scripts and the post-install scripts. Basically, this is a script which should be executed after your package is installed. So I'm in our concise logger library. And here we have the script post-install, and here I can call anything I want. I'll tell you from the start, I will want to illustrate this for you, but currently it is not working. I don't know why. Either Node has disabled this for good, or there's a problem inside my Verdaccio registry. Anyway, I'll show you how exactly this behaves. In this project, I will create a new folder and I will call it scripts. And here let's just create a new file called post-install.js. Let's just print a console log here. Let's just say here, this is malicious code, and save this. And now in our post install, we can call node and our scripts post install. Let's see if this is working locally. So locally I can call npm install, and when I will call npm install, Node will directly call this post install hook. You'll see we see this console log. Let's now publish. I will publish to my local repository, to my local registry, this new version. I will make this a version 10, and I will call npm publish to my local registry. It's now published, and let's move into another package and install this concise logger one more time. Let's work in this local package test. And here let's install the version 1.0.10, the one I just published. And I will call here npm install. Yes, of course, with our registry. It installed. If we are checking our node modules, you will see that we have these scripts and we have this package JSON right here, which should be executed. As I said, this is the basic principle behind this vulnerability. I think Node disabled it for good because it caused a lot of issues. You know, you are just not careful, you are misleading, and you have a typo in your package name. You want to install React, for example, and you're not careful and you install Reacts. And maybe this Reacts package has a post-install script with some very malicious code. I will put in the resources for this lecture some articles relating and debating this a little more, and you will understand what big security issue these post-install scripts are. Yeah, well, because they are not working, there's not much we can do to be very careful in this direction. If for some reason for you this will work, there's another very important point that you need to do in order to make sure these post-install scripts are not executed. You can install your dependencies with the flag ignore scripts. So for example, you can just call anytime you install something with the flag ignore scripts. This is the one. And it will ignore by default the scripts. Or an even better solution, you can override this setting in a local npm rc file, and here you can just specify this ignore scripts to be true. And this way, even if you install malicious packages which have malicious code in the post-install script, all the scripts will be ignored during installation. Let's quickly talk about other security concerns in the NVM environment. Well, I talked about one briefly in the last lecture, and that is typo squatting. It's a strange word. I'll print it on the screen. What it means that some malicious developers can mimic different packages and add some functionality which is very bad. And how can typo squatting affect you? Well, you call npm install a lot in your developer life. Well, you can call npm install, you want to install React, you're not careful, you install something like this. Well, this can be a valid npm package, it can be installed and it can mimic the functionality of React, but it can also have other functionalities which are really bad. Well, the point right here is to always be careful for typos when you call npm install. And also you should only install popular packages. You should not install just everything you see on the npm registry. It is huge and its maintainers have a hard time making sure that everything is not malicious. Another point which I want to make is that you should periodically assist your project health. And npm has two commands which help you with this. One is the npm outdated, which we talked in the versions part of this course. Currently, I don't have any dependencies in this project, but if I would have outdated dependencies, they would appear here, so I would know and I will be aware to update them. Another command is the npm doctor command. I will call it, show you what it does. Well, it went through some different configuration of my project and of npm. And as you can see, it did some checks on the local and global node modules, on the configurations, on the registries, on the Git. And also it can reach npm, which is great. It found a problem with my npm version, which is not the latest one. Let me fix this real quick. I'll call npm install globally npm at the latest. Yes, with a sudo. Alright, now this is also good. Let's see if npm doctor is happy now. Yes, npm doctor is happy now. Now everything is alright. And one last point which I want to make is when you are developing some packages and you are developing not for open source but for your company, it is very important when you are developing a package, a private package, to specify this in your package.json file. Here you have the option private and you should set this to true. And this way it will tell npm that if you want to publish, it will make sure that you are publishing on a private registry, not on the public npm.js registry. This is an important check and easy check if you are developing your own packages or a package for your company. Well, this was by no means a complete recommendation for npm security. As time goes by, other problems, other tools might appear. Make sure that you are always up to date with the latest best security practices for your development. In this lecture, we will have a different discussion because we will talk something that I got from only from experience. It's not something very well documented, and I will give you a direction or an advice which I learned over the years on how to use different external libraries. And when I'm talking about external libraries, I'm talking about, of course, smaller external libraries. If you, for example, would have a project which would be built around the AWS SDK, of course, it will not be easy to switch to another library. Of course, if you would switch your cloud provider, you will start your project all over. But let's say that we are using small libraries like this UUID library that we are using inside our Node project, our concise logger project. How we can use this library in order for it to be easily maintainable over the years. So what do I mean with that? When you are working on a big project and you are working for enough time on it, eventually you will have to handle your own mistakes or your team's mistakes when you are dealing with packages. And I want to show you a way in which changing a package or handling a package can be very easy to do over the years. So when you are building something, you want it to be successful, and for it to be successful, it needs to be up for more time. So you need to think big over time. Well, enough talking, and what I want to show you is a way in which we can use these dependencies. So in our logger file, in our concise logger file, at some point we are printing an ID, a log with a random generated ID, and this ID we are getting it from inside the UUID library. A much cleaner way in which we would use this library would be to just delegate it to a internal local class in our project. What do I mean? Let's create a class right here. So let's make a lib folder. Let's make this lib folder, and let's create a class ID generator. And let's delegate all the uses of this UUID package inside a single class inside our project. So here I will say import our function from UUID. All right, and let's import this v4 right here. And now let's create a method, export function get random UUID or ID right here. And right here, let's just return this v4, just like this. And this way, we are delegating all the calls to this library inside this function. Now, the next step would be to always use this function instead of calling directly the library. Let's do this inside our project. So right here, I will import, and this is a local import, so it will be with a /lib and our ID generator. And here, let's just use this get random ID. All right, and this was the very simple change that I wanted to point out. Let's see if our project is still working. I'm using tsnode in order to directly execute TypeScript code. If you don't have it, you can just install it as a global dependency. And of course, our library is still called, so very nice until now. What is the main advantage of this approach? Well, I said think big over the years. Over the years, maybe a better version of this UUID library will come out, or you will find, or maybe a big security issue will come along with this library and you will have to change it. One way, if you would always use this library inside your code, you will always have to change all your references to this library. But now, if you delegated it to one class, all you will have to do is to change directly right here. And the second point which I want to make, now that we delegated this functionality to a different class, the point which I want to make is that you can even avoid using this class at all. Well, if we are looking at this import, this is the v4 import, and we are looking at our node modules, our UUID package. If we are looking at this v4 library, you will see that it will get this native default random UUID. Let's see what this native.js is. So let's go to this native.js function. And if we look here at line 8, you will see that it will just get this crypto module, which is a built-in Node and browser module. Well, this means that we can avoid using this library altogether. Well, if we would build again our project and we will use everywhere this UUID library, we would have to change everything. But now we can directly change things inside this class. So instead of using this library, let's just directly use that crypto package. Import from, and let's call this crypto package. And the function that we are using, if we look here, is this random UUID. So inside our import, let's just use this random UUID and let's just return it right here. Save everything and let's see if things are still working. Let's even delete this dependency right here, the types to UUID right here. Call npm install one more time to update all the references. Clear this. And let's see if our package is working now without this library. And as you can see, the functionality is exactly the same, and now we avoided using an external package altogether. This is great, and this is a great way in which you can make sure that sometimes you can avoid using different packages because they mean maintaining them over time and they also mean security issues. In this lecture, we will see how we can create different C++ Node.js add-ons. And what they are a way in which we can call C++ code inside a Node.js project. We will have 3 parts in this lecture. First of all, we will create a hello world C++ project. Then we will create some other functions to see some performance parameters. And then we will create a function which takes some parameters and calculates a simple sum. Let's get started. I will create a new folder and I will call it Node add-on and open VS Code inside it. Just like we are used, first of all, let's initialize a simple Node.js project right here. So I would say npm init -y. We have a package.json file, and the package that we will be using is called NodeJS. This is the one, and this package will compile C++ code in a way in which Node.js can understand it. So we will install the package NodeJS. I hope I spelled it the right way. Alright, now we have this package NodeJS, and let's call it inside our scripts. Because it's a local package, not a global package, we need to define a script in order to invoke it. And what we will do with this NodeJS, let's create a script which is called build, and here let's invoke this NodeJS package. So NodeJS, so GYP, and the commands that we will be calling with this NodeJS, because if we are checking now our Node modules, you will see that we have an executable which is called NodeJS. So we can call this NodeJS right here with configure and with build. Very important, in order to invoke this NodeJS library, you need to have Python installed. So in order to execute this, you need Python installed. I will check this. Currently I have Python 3 installed, version 3.10, so it will work for me. If you don't have Python installed, take a break and install it. I have it right here. So we have installed this library. This library now needs a binding file, a file which tells it what exactly to do. So I will create a new file and I will call it binding.gyp. No, not here. And in this file, we will configure the way NodeJS will behave. This will be just a simple JSON structure. I will call here a targets, which again is an array of objects. And here we have a target name, and this will be a add-on. And we have a sources, which is an array which will contain our source code for C++. So our file that we will be working on, let's call it addon.cpp. This is the one. Here we will put our C++ code. So in our binding.zip, we will say that our sources contains with this addon.cpp. All right. This is a very simple binding file. And let's now create this addon.cpp. I will just paste the code, and I will explain it. Let's just first create a very simple hello world function now. So I will include a node and let's just create a very simple hello function. This is the one. It's a void hello function. This is the name of the function, and what it will do, it will return to the arguments this string. So when we will execute it, we will see this hello world right here. As you can see here, we are using the v8 function callback info. This means that we need to use this, and let's see if everything is all right. Let's now invoke npm run build, and everything is okay. This will create a folder right here. Okay, I have an error. Let's see what's the problem. All right, it needs to know what isolate means. Okay, let's try it one more time. Oh yes, and now it doesn't know what string is. No problem. We will also be using this v8 library with a string. One more time. And finally, our build is done, but we are not ready yet in order to use this function outside this node file, outside this C++ file. So we need to export this in order for Node.js to be able to use it. And I will create a method called initialize. This is the one. And here we will put our hello method. We will call this node set method. And now let's export this. And this is our final version of our simple C++ file. Again, if we are using this v8 local, of course, we should specify this. One more time. All right, now we are ready to use this function in our Node.js environment. So I will create here an index.js. And now let's use this library that we just exported. So here I'll say const addon, and we will use it with the require syntax, and we will just create the path to the build folder. So here we'll go to the build, release, and this addon.node. So here we will say build, release, and here we are using the addon. All right, and let's just print it. Console log, and here we'll say addon.hello. Let's check the function. And as you can see right here, we are exporting this hello function right here to this keyword hello. So this hello with a lowercase must match this hello right here. Let's see if this is working. So here I will say node index.js. And as you can see, we are now executing the C++ code that we just compiled. We were successful in this. Let's now create another function which will do some more computing extensive operations in order to make an idea about the performance between C++ code and Node.js code. So here I will paste another method. Of course, this is available as a resource for you. And let's just call this method sum. What am I doing right here? So I'm just making a sum, and for 100 million times, we will create and we will make an operation. Let's do this in C++ and then we will also do this with Node.js and see the difference. Here I'm using the V8 number, so of course I need to specify that I'm using it. Let's now build again our function. Alright, of course you don't have to type this yourself, this will be available as a resource for you. Let's now create a similar function right here in our index.js file. So here I will create a similar function. Let's just call this JS_sum. Let me delete this, we don't need it anymore. This is our function. And let's also call the sum from our add-on. Let's register it downstairs, of course. We are adding a new method called sum. And let's just use the console.time. So here I'll say console time to get an idea about the time. And this is the C++. And now let's invoke. So here I'll say console log. Let's also print the result, our add-on, and let's call our sum. And then again, console time end now with our C++. And let's do the same with our JS sum. So let me copy and paste this. Now this is JS, and let's just invoke here our JS sum. Save this, compile one more time. All right. And let's now invoke this JavaScript file. Before invoking it, what do you think it will happen? It will be the C++ code will be a lot faster, it will be just the same. Let's find out. As you can see, the C++ code is a little faster. I would dare to say that for these very simple operations, Node.js is also very, very optimized. So in the older versions of Node.js, this C++ time would be a lot bigger. But what advantages do we have when we are using C++ code? Well, not just these very simple operations, but when you are working with many objects and you want to handle the memory yourself, then C++ will be much faster because you can do things the very right way with pointers and not rely on a garbage collector. For this kind of operations, C++ would be a lot faster. On the other hand, a C++ code will give you much more access to the internal hardware of your machine, much more access than the Node.js code gives you. Alright, we saw some very simple performance benchmarks. As you can see, there are not big differences for simple operations. Let's now create a final function in which we will see how we can parse parameters inside a Node program. So I will create another function which is called add. And by the way, all these functions are taken from the Node.js documentation. I'm not making them myself. I will paste yet another command, another method, and this is called add, and this will just return a simple sum of two parameters. As you can see, this is getting the arguments. If they are not 2, then it will say a wrong number of arguments. Again, if they are both not numbers, it will again throw some error, and then we will finally return this sum. Let's also register this downstairs. So in the initialize method, let's also add this sum, add this add method, I mean. Build it one more time. Oh yes, I also need to specify that I'm using this exception. All right, we can use it. So in our index.js, let's comment this out. And let's now see if our parsing of arguments works. So here I will say console log our add-on, and let's now call the add method. Let's just call it without arguments, see what happens. As you can see, we are getting an error right here. It tells us the wrong number of arguments. But if we are putting the right arguments right here, let's see, 4 and 5. As you can see, it gives us the sum, so everything works as it should. So we saw in this lecture how we can use C++ code inside a Node.js project. As I said, maybe for simple operations, the performance is similar with Node.js because it is also very well optimized. But when you are working with memory extensive operations, or when you want to access the lower hardware of your machine, then these C++ add-ons are a great solution. Sometimes when a new version of Node comes along, you will want to quickly test how your code works with it. Or sometimes when you're working with a bug, you want to see how Node behaves in a different version. For this, there are basically two big tools which helps us a lot handling multiple Node versions. For example, in my computer I have currently Node version 18, but if I want to quickly switch between versions, of course I can reinstall Node at a lower version, but that would be complicated because then I would have to also reinstall back the version I currently use. So, as I said, there are two main tools which helps us handle multiple Node versions. Now, one is called NVM, which stands for Node Version Manager. It is a program which only works on Macs or on Linux, and it is a little more complicated. There's also another option, which is a Node package called N. So N is a Node package which helps us handle multiple Node installations. And we will see in this lecture how we can use it. Well, I will show you how we can use N. If you want on your own, you can search about NVM and see how it behaves. N is a Node package. We can easily install it with npm install globally N. Yes, with a sudo for me. I have installed N, and if I just enter it, it will tell me that it will show me what versions of Node I have installed. Currently, I only have installed these 18.12 versions. So I need to install a different version of Node. Let's try to do this. So if I want to install a different Node version, I can call N and the version which I want. Currently, let's just try 10.16.0. Yes, with a sudo. Alright, it is installed. Now if I will call N, I can quickly switch between versions. I will select this one and let's see if it worked. I will call node ---- version. And now you can see I'm using version 10.16.0. I can now use this version to test whatever code I want. When I'm done with it, I can just specify the other version which I want. Let's now switch back after we tested what we wanted with another Node version. Let's now switch back. So I will call sudo and our N. I will select our latest one. And now if I call node ---- version, you will see I'm using the latest one, which is great. So we saw how this tool helps us very easy switch between different Node installations. Let's now quickly talk about how NPM works alongside Git, and I want to make in this lecture two very fast points. First of all, if we look at our package.json file, this is a package.json file which I generated with the .y command, and I generated it when this folder wasn't initialized as a Git folder. If you are calling the npm init inside a initialized Git folder, let's see what happens. In the meantime, I initialized it. So if I will delete these two files, and I will call npm init-y again, since now this is a repository, because it has a Git file, a hidden Git folder, you will see that now we have the entry repository. It gives us the URL of our repository. Also, it gives us a home page, a bugs entry. Of course, this is all information taken from GitHub. This was one point which I wanted to make. You can put all kinds of information about your repository inside your package.json file. The other point which I want to make is the point that you can install certain npm packages directly from GitHub. For example, I'm looking at the page of a popular Node package called Lodash, and we can install this package directly from GitHub. So if I'm in its home page, and in this repository, if I will take its URL, this one, the HTTPS URL, I can just copy it, and inside my terminal, I can call npm install and install this from Git. This is the one, and without the .git extension. And as you can see, now this package was installed directly from Git. You will see these dependencies right here, which is this Lodash package, which is directly taken from GitHub. You can play around with this, and the documentation shows us that you can even specify the version of the tag or the branch which you want to use. This is a quick way in which you can switch between different versions of a package if it is not published yet. To be honest, I never did this. I usually always install the packages from their releases, and if I want to test a package, I install it from a local path, but for your information, you can also do this with npm. Let's now talk about two alternatives to npm. And let's start this discussion with a very short history lesson. Well, a few years ago, basically at around 2016 and before, npm was very slow. It didn't have a log file, which meant a lot of errors because dependencies didn't align themselves with one another, and npm was insecure. Because all this problem npm was facing, Facebook came with an alternative to npm, which was called, and is still called, Yarn, which stands for Yet Another Resource Navigator. It was released in 2016, and it came to solve these problems npm had at that time. It was fast, it supported version locking, so if you can imagine, there was a time where npm didn't have log files. And of course, it was more secure. And a little newer in our days, there's yet another npm alternative, which is called pnpm, which comes with this selling point. It is very fast, and in this lecture we will understand why. Well, this was a while ago, and as you saw in this course, npm came around and fixed all these issues. As we speak, npm is also fast, it supports version locking, and it is a lot more secure. Anyway, you may try Yarn or pnpm, and of course, if you like it or if you like them, you can use them. If you don't like them, don't use them. Simple as that. Don't just hate a tool because you don't like it or it's not suited for your needs. But since we are learning in this course, let's try to understand how these two alternatives work. If I'm looking at the npm trends page, this is a page which I really like to consult. As you can see, in the last years, Yarn is becoming more and more popular, but this other alternative, pnpm, is also taking the lead. Let's now talk about these two alternatives and let's try them out. And because both of them can be treated as packages, they are both NPM packages. This means that we can install them very easy if we already have NPM installed. And if you want to learn Node, NPM comes installed by default. Let's first try Yarn. So I will select a terminal on my computer and install Yarn as a global dependency. Sudo npm install as a global dependency Yarn. Alright, I have installed Yarn. I can check it with yarn -version. Alright, let's now try this, and in order to try it, I will just create a new folder on my computer. I will call it yarn practice and start VS Code inside it. And how we can start, or how we can initialize a Yarn project? Well, very easy. Most of the commands that work with npm will also work with Yarn. So let's create a project. I will call Yarn init, and I will just go to the defaults right here. And as you can see, this also creates a package.json file. It is a lot more minimal than npm. As you can see, it only contains these steps. Let's now add a package, and I will call yarn add. This is the alternative to install, and let's add a package which has a lot of dependencies, like the testing library Jest. Alright, it had installed our package. As you can see, we have a node modules folder, and this Jest library has a lot of dependencies. And very important, you saw that now we have a yarn log file instead of a package log.json file. This log file makes the difference between the tool that you are using inside your project. So npm creates a package log.json file, yarn creates a yarn log file, and pnpm will create a pnpm log file, of course. So this log file shows you what tool you are using inside your project. Let's now see how we can run a simple script. So let's create a simple scripts entry right here. Let's create a test script, and let's just call Jest right here. And we can run scripts with yarn run and our test. And this executed Jest. Of course, we don't have any tests, so it ends up with an error, but this was the way we can use Yarn. Well, if you want more, you can try it, you can read the documentation. I will prepare a list of commands for npm, for Yarn, and for pnpm attached as a resource for this lecture, so you can make a better idea about how Yarn works. Let's now try the other alternative to npm, which I announced at the beginning of the lecture. Let's try pnpm. And pnpm comes with the selling point that it is very, very fast. So let's install it. I will just call sudo install, again as a global package, pnpm. This is the one. We have now installed pnpm. Let's also create a folder right here, pnpm practice, and start our terminal right here, our editor right here. Again, first let's initialize a project. Very simple, pnpm. Let's see if it is installed. Let's just call version. Oh, it's -- version. Yes, it's with -- version. Let's again pnpm init. Alright, this has created a package.json file. As you can see, by default it takes the defaults. It doesn't ask us for any input. But the key difference for pnpm is the way we install packages. Again, if I will call pnpm install Jest, for example, let's see something interesting. And some interesting things happened right here. First of all, as you can see, we now have a npm log file, which specifies that, yes, of course, we are using npm inside this project. We have now this jest dependency, but let's check this dialog inside the terminal. And as you can see, it tells us it resolved 277 packages, but it downloaded 276 packages. So the way npm works is by downloading packages inside a location on your computer, and then if you use them, it will create links inside your computer. So if we now check our node modules, you will see that it is much more clean because it has a dependency to jest, but if you look, you will see that this is a symbolic link to this package jest. This means that for each project inside your computer, we won't have a copy of your packages. Instead, npm will just link them inside your project. And this makes downloads a lot faster. Now, if I will remove this package, I will call npm remove jest. Alright, it had removed jest. Now, if I will install it again, you'll see that it resolved 277 packages, but it reused 276 and it downloaded 0. This means that it just used a local cache of this package and it didn't went back to in the internet to download this package and make a copy, a local copy right here. This makes npm a lot faster. Of course, the same way we can call scripts. For example, if we have the test right here, and we can call jest. Again, scripts works exactly the same, npm run test, and we can execute our tests. Again, an error because we don't have any tests configured. So we saw in this lecture two alternatives to npm, pnpm and yarn. You may try them yourselves and if you like them, of course, you can use them inside your project. Let me quickly show you a very clean way in which you can handle the growing number of packages on your computer. As you will work on more and more projects, you will get more and more node modules inside your computer. You will have local caches of different tools. So you will have a lot of memory consumed with node packages. How can you see which node packages take the most memory of your computer and clear them very elegantly? I will show you a very clean way in which you can do this using a package called npKill. And we can directly execute it with npx. So I will call npx npKill. And this is a process which will show us how exactly this and what is the state of your node modules inside your machine. As you can see, it tells us for most of them when were they last modified and also their size. If we go through them, you will see that, for example, this sample app has a lot of space which it takes. If I press space, it will directly delete it. Lower down the line, we can see the packages from the cache for npm. I will just leave them right here. But from time to time, you can use this tool to see the state of your node packages and clean them in a nice, elegant way.